Okay, the purpose of this video is just to clarify sig figs and how they relate to concentration and pH. Basically, the number of sig figs, in a concentration of something is equal to the number of decimal places in the pH. So for example, this question, this is a concentration, and there are 1, 2, 3 sig figs. So when I determine the pH, I'm going to have 3 decimal places, or 3 places after the decimal point. Okay, so let's do this. pH is equal to negative log of the hydrogen ion concentration. So it's negative log of 0.00150. Okay, let's do that on, let's do decimals. That doesn't look like decimals. I was sure I had that ready to go. Cancel that. Browser. There, that's better. Okay, so I need to go negative log functions. Where's my log function? Log, and it's assumed base 10, so that's good. 0.00150. Okay, so the pH is negative. Oh no, not negative. It becomes positive. 2.823987, etc. So to do sig figs, here in the question I've got 3 sig figs. So in my pH I need 3 decimal points. There, there, and there. So it'll be 2.82, and because this one's bigger than 5, this one bumps to a 4. So that'll be correct sig figs for the pH. Let's try one going backwards. Oh, yeah. Oh, this question says find the pH, and then it says find the pOH. I should have done that too. So to find the pOH, I just go 14, take away the 2.824. So it'll come out to what, 11.176, I believe. 3 decimal places, 3 decimal places. Let's go backwards. So they say the pH of a solution is 12.03. What's the hydrogen ion concentration? And what's the hydroxide ion concentration? Another good question. So just looking at sig figs right now, the pH, the sig figs of a pH are only the decimal places there. So there's only 2 sig figs. So in my concentration, I can only give 2 sig figs. Here's my formula. Hydrogen ion concentration is equal to 10 to the minus pH. So it'd be 10 to the minus 12.03. Okay, let's try decimals again. Browser. This guy. So I have to go 10 to the negative 12.03. There we go. Okay, so my concentration is 9.332543, etc., times 10 to the minus 13th. In other words, the concentration of hydrogen ions is very, very small. Now, for sig figs, this has 2 decimal places in my pH, so I can only give 2 sig figs in my concentration. So it'd be 9.3 times 10 to the minus 13th. This question also asks what's the hydroxide ion concentration. I think I put this in the video. I don't think I did this in class, but One way you could figure out the hydroxide ion concentration is this formula. So hydrogen ion multiplied by hydroxide ion is equal to 1 times 10 to the minus 14th. And this has unlimited significance, and so it won't change the sig figs. So to figure out hydroxide ion concentration, I take 1 times 10 to the minus 14th and divide it by whatever the hydrogen ion concentration is. So 1 times 10 to the minus 14th divided by what I just got, 9.3 times 10 to the minus 13th. Let's see what that comes out to. I don't know if I can do this in decimals. Have to be able to. So 1, maybe I just try this like that, times 10 to the minus 14, okay, divide, oh, I don't like that, oh, that's all right, 9.3 times 10 to the minus 13. Yeah, that number looks about right. Let me move this up a bit. Oops. So that concentration would be 0.010756, etc. I need to round to 2 sig figs, right? 2. So it'd be 0.01. So there's 1, and this one has to be at 2. Since that's bigger than 5, I'd bump the 0 up to a 1. So that'd be my concentration of hydroxide ions. All right, hopefully that helps you figuring out sig figs in a concentration to decimal places in a pH.